tutorial is going to cover FM synthesis, which is a very simple way of taking just a couple of different waveforms, adding them together with some other parameters to create complex sounds. And this is a very tried and true way of creating complexity with not a whole lot of effort in electronic music. This was very popular in the early 80s with 80s synthesizers like the DX7. Also, the Roland 808 drum machine used FM synthesis to create complex sound. So I only need technically three different things inside my FM synthesizer. The first one is the carrier waveform, and this is the primary waveform for the signal that's coming from, in this case, a keyboard that I'm going to use. The second is another waveform called the modulator. And that waveform is going to basically be added into the carrier waveform to make it change over time. The last thing is the mod depth. And essentially, this is the intensity of the modulation waveform. So this is kind of like the amplitude of the mod waveform. So the first thing we're going to do is MTOF, right? We're going to convert this MIDI note into a signal. And from there, we move on. So this is primarily your carrier wave. So, another thing to think about the way this kind of works is FM radio. That's where we know the term FM. And if you think about FM radio, we have a carrier waveform. The carrier waveform is kind of like 91.5. That's the station you're turning to. And then on that station is another waveform, right? The actual music or the radio or the talk radio, whatever it happens to be. So our modulator here and our mod depth, the modulator again is a cycle object. So we have another cycle tilde, and we're going to add in signal to this. And then we're going to multiply the signal together with the mod depth. So the mod depth is another variable that's going to come in. And I'm going to set this to an initial value of 1 so that obviously whatever's coming out of here will be nothing. It won't change the sound at all. But I have my mod depth modifier here that will allow me to change it over time. So after all of this, what we're going to basically do is combine these together and send them into another cycle object. So I'm going to add tilde. This is adding audio signal together. So the waveform comes in here. We add it to the modulator, right? This object here, which is or this waveform here. And we're sending both of these into another cycle object. So that is essentially it. And then from there, I am sending this to my mixer, okay, or to my mute button. So I'm going to make some gain tilde objects here. Let's change their color. I always like to have nice red, dark red gain objects. We'll connect these together. Let's make them both a little bit wider. Okay, and then because we are going to want this to be stereo, I'll run both of these into here, left and right, and then run the cycle into each of these. So we're taking basically a mono signal, right, and turning it into stereo pretty simply. So this is all we need to make FM synthesis, all right? As I play MIDI notes on the keyboard, like middle C, you can see middle C is posting as 261 hertz. It's going to play out, right? So right now, if I turn this on, we won't hear any FM. We're hearing simply the carrier waveform, which is a single sine wave. But if I start to add the modulator in here, like 40, and then turn up the mod depth, we start to hear the changing of the frequency. So it's a really interesting way of creating complex sounds, again, with literally two oscillators. I have the cycle oscillator here, right? If we make this red, and then my other one is right here. So that's it. These two are being added together to create this complex sound. Now the mod depth can get really big and it can really change the sound a lot. So let's really crank this up. You can hear the complexity, the change of that sound. It now has a lot of different frequencies involved. Similarly with the modulator, I can really crank with the modulator to also change things over time. Now, there are so many cool things we can do with this now. If I want to create complexity, I can do some neat stuff. So one of the first concepts to remember too is that there's another concept here called the ratio. And it specifically is the ratio between the carrier and the modulator. And the general concept here is that if the ratio is kind of a whole number, for example, if I multiply the carrier by 2, if I multiply the carrier by 3 or 4, whole numbers, if I get good ratios with it, we're going to end up with a really nice sound, all right, and kind of a harmonic sound. So let's use the carrier waveform here to actually change the modulator in time. So if I, for instance, take the carrier and multiply it by 2, so instead of the carrier wave being static, it's now going to always be a multiple of 2. We'll get a harmonic sound. So you can hear that that sounds fairly nice. And if I, for instance, add a dial, let me add a dial on here. I'm going to take this dial and give it a value. Well, it has a value of 128. Let's also give it a float output. So it's always giving me something. I can get lots of enharmonic sounds. So if I add this in here, and let's also just put this here so I can see what value is coming out, you're going to hear how much this changes. Another thing we'll do, well, let me just add another one of these above here so I can enter integers like 2, 4, 6, 8, whatever I want to do. So let's hear what this sounds like now with 2 in here. If I do 3, if I do 4, oh, I need to enter the notes again each time. So you can hear now it's added an octave above. If I enter 4, but if, for instance, I enter 4.17, listen to what happens. It's starting to get an edge to it, right? You can hear the edginess. And if I want to make this change while I'm doing this, I can, oh man, this is getting really tight in here. Let's kind of spread this out a little bit. Pull all this over here, move this out. Grab all of this, because, you know, essentially here what we're doing, right, is we're changing that mod index over time. Or, yeah, the mod index, the mod ratio. So I'm multiplying the modulator by my little thing here. I can also trigger, I think I just need a trigger for this to there, and then this will change in real time. Otherwise, it needs a change each time. There it is. So you can see now what's happening is it's re-triggering this every time and recalculating the number in real time. So with a mod now of 14.3, you can hear how enharmonic this is. So, so there is a lot that we can do. If we just set some basic parameters here. If I set this to 200, for example, put this at 200 as well. Let's hear what we get. Let me remove all of this, and we'll just go with these basic values. So you can hear kind of the fluctuation going on in the sound, right? So, for example, one thing that I could do is trigger an envelope to affect the mod depth, right? So let's use the function object, sorry, it's not tilde. Add on the line tilde at the bottom. And I want to take all these the values of this line as just a list of numbers, right? In fact, so I need to use the number tilde object, attach this here, and then run the values of it into this box, okay? So a couple of things we're doing, and this is going to need probably a scaler, because I can now create an envelope. Let's make an envelope here like this. But the value of this, right, is 1 horizontally, or vertically, sorry, and 1,000 horizontally. So when I trigger this bang, it's going to show me all the values, right? We're outputting the mod depth now. The mod depth is changing over time to 0. We probably don't want that to go to 0. So what I'm going to do is scale this first. Scale. So remember, the value is between 0 and 1, essentially. So 0 to 1 is going to become 200 to maybe, let's try 2,000, or let's try 250 and see what we get. So now the mod depth, the output there is going to connect here. So let's hear what happens now when I play a note on the keyboard. Oh, so the mistake I made is I need to trigger this envelope every time I play a note, right? So, and yeah, it's going to do something kind of annoying where it triggers the note on and the note off messages. But let's just do it for now, this like this. So let's hear what this sounds like. So it's not making a huge difference right now. So maybe this mod scale needs to be more. Let's try 650 here. Let's try it now. Unmute. So you're hearing the note off messages too. Okay, and if we connected this now, so again, this is on all the time, which is not ideal. So let's make this again, copy this whole line, use it twice. And down here, we'll add another multiplier, right? We're going to do the classic thing that we've already learned in this in class, which is to multiply the audio. We'll start with 0, so it's at 0. I'm going to move these cables here. And this is going to be our amplitude envelope, right? So this now is the amplitude envelope, and it also needs to be triggered on every note. So let's hear what we get now. And again, we're going to get the doubling of notes, right? But if let me zoom out a little bit. So let's hear what this sounds like. So interesting sounds. We're getting better, right? If we add some reverb in here, it would probably really help. Let's grab the reverb just to make things sound even more interesting. And again, this is just kind of it doesn't really change anything. So let's grab these. And then I'm going to run, yes, the main, well, no, let's do the main signal after the envelope here and then into the volume control. I'll turn this up and let's hear this now. Oh, muted. So anyways, so there's a lot we could do here, right? I could do some neat things. If I wanted to avoid this double repeat, right, we could do, instead, I could just enter notes. So if I play notes here, we won't. We're still getting a little clicking and popping, especially if I play notes faster than 1 second, right? Because this envelope is 1 second long, specifically this one. We're getting that click. But if I don't, we don't. Let's change this mod. So really cool sounds. There's a lot going on here that you could do some neat stuff with. That's it for this tutorial.